All right, today I'd like to start in on how to use CoreData. When we look at my notes, let's just start with that and we'll come back. Well, actually, before I start in my notes, let's download real quick this bank list SQLite. That is an SQLite database. It's got a bunch of bank information in it that about banks that have failed and when they failed and who bought them. And it's just something I downloaded from the US Gov site because they've got all kinds of comma separated value databases out there. And last year, Wonderlic had a little mini app that you could modify to convert or to read in a CSV file and convert it to a SQLite database. So I've already done that. If time allows, we'll kind of go through that process. It's not terribly complex, but it does allow you to get data from other sources because you can use Access, you can use PHPMyAdmin with some modifications to create CSV files and then import them into your iOS app if that's what you want to do. So download that, just put it someplace convenient, and we'll park it in the right spot. If you want, you can download the icon as well. We'll put that in real quick.
I'm sorry, what was the new password?
New password is student 2014.
Okay. Yeah, lowercase s?
All lowercase, yeah. I'm just putting mine on the desktop. And let's do a little bit of overview first, and then we'll get into the meat of this. Just like with the master detail apps, when we're going to create a new project today, and when we do, we're going to designate that we want to include CoreData in our app. And when we do, we're going to get all kinds of boilerplate templates that help us get our job done. Someday, 5-6 years in the future, if I'm still here, I hope to take this back into the raw elements and talk about how all the pieces, parts link together. But I'm not sure I understand it yet. This is one of those where I have a boilerplate, I tweak it, it works. Get on with life if I don't necessarily understand how all the pieces work. I think there may be some advantage to understanding that so that if you do want to modify how this works, it's a little easier to do. Right now, we're just getting a database application to do what we want it to do. All of our apps so far have not had persistent data. We run them, you create a sample array of data, and when you close your program, the sample array is erased. And you run it again, it starts with the fresh data. It's a good way to learn about master detail apps, but in Adam's recipe database, if he wants to add a database and make it be there the next time he runs the app, we need some persistent data. Persistent data is typically done with either text files or databases. We're going to skip the text file component. If Sean has done that, we'll have to play a little catch up next semester. But we're going to use CoreData. As we read in Jack's tutorial last time, there seems to be a replacement for this, but I'm not ready for that yet. Right, so I'll take a little bit of a look at that, and maybe we'll take a little side tour of it a little later. But for right now, this still seems to function to a reasonable extent. I haven't got it working yet, but that's where you all come in if we get that far today. First, we want to get the concepts out of the way. So what we're going to be doing is using CoreData to store our data. And Wonderlic says this is great for non-trivial data storage, meaning a little bit more than what a text file could handle. The other common type is a text file that actually is a JSON file or is some kind of an XML file that contains the data with scripts, and iOS does have XML classes to analyze those. There's just a lot to cover. So we're going to stick with this for right now. We're going to use a SQLite database. And we're going to copy, and we just copied that down from the website, and we're going to copy that into our project. One thing to recognize is CoreData, the concept, is not a database. What CoreData allows us to do is kind of the same thing we did with master details. Remember when I described the master detail app? If you had an array of 10,000 elements in it, the master view, the scrollable master table view, only shows as many as fit on the screen, plus or minus a couple, or plus a few at the top and bottom, so that when you scroll, it can keep up with you. Same thing happens here. If you have a database of 100,000 records, they're not all brought in at once. If that was the case, we'd overpower the memory of most devices today very, very quickly. So instead of bringing all the data in, what CoreData allows us to do is create this structure that goes out to the database, grabs what it needs to fill in the table view, and what's amazing to me is it's still really, really fast. If we put this on a device, and Sean's taken all the devices, so it'll be hard for me to demonstrate, maybe on my iPad we'll do it, but if you fling through those, it doesn't have all the data in the database, but as you're flinging through the records, you can't tell. It's just going through, and if you stop, it stops, and you fling the other direction, it adjusts again. So it's constantly updating itself, constantly keeping a minimal amount of data necessary in your memory, but making access to the database almost seamless. So it's not a database itself, it's a class that allows us to get to that data, get minimal amounts of data, and bring it in as needed. Very, very powerful. Can't imagine, though it sounds like they have, I can't imagine they've improved on that, because it is really slick. So let's create a brand new project. So start up Xcode, and we want to call this failed banks, because that's the data that I happened to grab that had any interest in to me at all. There's another one with Congress members that you'll use for your project if we can get when we get all this working. But there's tons and tons of data out there. So I'm going to start a new Xcode project, and where you have to be careful is I do want to do a master detail, because master detail comes in very handy. Here's a list of your records with the minimal amount of data for selecting, very similar to what we did in programming logic, and you'll see a lot of references here to programming logic because the concepts are very, very similar. So we're going to create a master detail app where we pick the records on one screen, and then the detail record shows us the rest of the fields. And if I remember right, allows us to edit them and bring them back again. Click on next, and the next screen is the one you really have to watch out for. Let's call this failed banks. And you want to make sure that you're Swift, we're still going to stick with iPhone, and you want to use CoreData. If you don't check that, you don't get the boilerplate code for CoreData, and you might as well start over. Yes, sir.
Is CoreData like defaulted in Xcode? Because with that
It's a built-in class
So with that new one that
that Jack did, yeah.
Jack
I forget the name of it, yeah.
that obviously is
Also built in.
it's built
It
in.
may be a layer on top of CoreData for all I know.
Okay.
Okay. I wouldn't be surprised if they simplified some of this CoreData stuff.
Right, because I didn't see like a select list, so I was wondering.
Right.
Like, how does that?
I don't know. Not for the new one. And I don't know enough about this one to remember I said all the foundation I don't necessarily have a good handle of. I can kind of get a picture for what's going on here. All right, so there's the key. When you create your project for Unit 6, make sure that you use CoreData. Click on Next, put it wherever you want. Put mine on the desktop so it's easy to find. And while we're here, since we got the icon, I'm going to go grab the icon. If you skip this step, don't worry about it. No, I forgot how to do this already. Just drag it in there, right?
Is that under the 2 times?
Let's see what happens. If it complains because it's too small, I'll move it over to 2, or I'll put one in 2.
Into this, it gives you a warning.
So it gives me a warning in 3 because it's the wrong size. So there.
Yep.
I just moved it.
Warning.
Okay. Now, what's happened here? Well, first of all, let's notice that the app delegate is here, the master, the detail view, all that's pretty much the same. But what's new is we have this XC, Xcode data model. We're going to be using that to describe our database tables to Xcode because it needs to be able to go out and grab this data. But before we do that, the next thing we want to do is add our database to I call it in my notes, I call it the bundle that's left over from Android. Android, the project is a bundle. Just need to drag this SQLite database into here. We could put it in supporting files or wherever. I'm just going to tuck it underneath here. Okay. And add it to the targets for failed banks. And copy it. That add targets is something I think I might have forgotten to do in my office, and maybe that's why I couldn't get the data to come up. Click on finish, and it should copy that over, and now our bank list SQLite is ready to go. It's getting later and later as the semester goes on. Pretty soon you're just going to have to bypass this whole class here. All right. So we got icon. You're 5 minutes late. Is that what you said?
20 minutes late.
20. Yeah. Well, it's 5 minutes late for you because you're usually 15 minutes late. And yes, the recording is going. But anyways. All right. So we created a new app for those of you who just walked in. Added an icon to it. The key is that when you create this app, that in the screen that allows you to pick the name of it, you also designate that this is a CoreData app so that we can use database. So let's go then to the app delegate file. And we're going to take a look inside there in just a minute, but let me follow back to my notes and follow along here. So we checked that box. And then off on the side here, it also says ensure CoreData is selected. That'll save you a bunch of grief. Like with master detail apps, when you create a CoreData app, you get a lot of boilerplate code. In order to communicate with that database, CoreData needs a few models. The first one is the managed object model. What does the data look like? We're going to hopefully describe that today. So we already know, I know what's in that database because I built it. Okay. I'm just going to transfer that. I'm going to have you transfer that information into CoreData. So here's what you'll find out there, and let's talk to it. We're going to use a visual editor. That's what this thing is a visual editor to let us describe the database. So that's very handy. We don't have to include all the tables in our database. We don't have to include all the fields. We hesitate on that one because I have not found a way to select fields just yet. And it doesn't have to be an exact duplicate of the database. iOS says that when we create these things, it calls them entities. I wish they would call them views because that's really what, in my perspective, that's what they are. An entity to us is a table. And it can be an entire table, but just like in C# in Visual Studio, we created table adapters that said, I want this, this, and this, and this from there. And we created basically a view. It was a query, right? We said select these fields. That's a query. That's a view. Kind of what we're doing here. And just like a table adapter, that view isn't really, this managed object model isn't really data. There's no data, and it's just a description of the kind of data that we're going to get. And again, as I just mentioned, I liken this to the table adapters that we did in C#. They describe how to get the data, how to sort it, that kind of stuff. And then we need some way to store that data locally in our app so that we can modify it, or at least use it for that matter. All the books and even the Wenderlich tutorial talks about how CoreData has a managed object context. We're going to play with that in the kind of the second half of this. I don't have the assignment broken up into two parts, but one part is get the data so you can display it, and then again, change the data. The context lets us do that. Context is like Scratchpad. It's copy of the data that we're currently playing with from the database. It's just a copy. Very similar to the data tables in C#. What's different here is the data tables in C# had every single record in the database that we requested. Versus here, it has access to every single data record that we request, but it only brings in as many as it needs, again, to fill the table view plus a view. Right. So it's a little more powerful than that data view. It helps us keep track of what records were changed, which ones were deleted, which ones were inserted, and at some point we have to issue the command that says, I've changed things, take what's in the context, and put it back out to the actual database. So the context, I'm going to call it Scratchpad. I think that works really well. Is copies of the records that we are currently viewing on the screen that we can manipulate, and then as we change them in the details view, we have to make sure that we update the actual database itself. Finally, there is a persistent store coordinator, and if we scroll through down this, by the way, if you just come down here, I'm on line 50 of mine here, there is a mark. I want to call it a pragma because that's what they usually, but it's a region is what that is. There's a region marked CoreData, and here's all the stuff that was built for us in CoreData. Notice there is a managed context. That's what I was just talking about, the Scratchpad. And this is the persistent store coordinator. The persistent store coordinator is basically the connection string. It keeps track of where's my data, and in this case it also keeps track of which records am I currently looking at. Does all of that, and if there's a problem loading, it goes through all kinds of fun stuff. So there's a managed object context, there's a persistent store coordinator, and there's a model. All of that we need to mess with a little bit. But again, take a look at the code. There's a couple of hours of lecture, they're just talking about how these things coordinate with each other, but they do.
It even says failed banks.
Pardon me, failed banks isn't there yet, is it?
It is, yeah.
Really?
Yep.
Wow, I should have done that before. I think I missed that step. If you missed what if you don't remember what I'm talking about, when we were building this project, we brought in the failed banks, copied them over. And in the process of copying them over, there was a checkbox that says tie this in. I didn't do that in my office. I must have missed it. Right? Because I had to do a lot of tweaking here to make things work, and this may actually be a lot simpler than I'm even going to be able to describe here. Because it did bring in, there it is, the failed banks. All right, and I didn't get that to happen in my office, so I missed a step somewhere along the way. I'm not sure because of that this step, this locating the database, is absolutely necessary. I think they've cleaned this up by allowing me to copy that in and assign it to my project. We might not need to do this anymore. But I'm going to keep at it because I think there's some value to this. Where'd the database go? Does it really matter? Is my newest question. I'm not so sure we care where the database is stored, but in the older versions we did need to know where it was so that we could drag stuff in there and find it and back it up and do those kinds of things. Finding this is a real pain. And I've taken some notes out here if none of you've printed them, so that's good. This is new as of this morning. I've taken some stuff out of here because I used to tell you, here's where it was last year, and it was this path that was about 3 lines long, and now it's worse. So I didn't even put it in there anymore. And it's in a hidden folder. As it turns out, our simulator, iOS simulator, has its own memory on our host computer, and that memory on a host computer includes a location where it stores its sample databases. On the actual device, there's probably another kind of path where that stuff is stored. In Android, we could get to that path using special programs. iOS, if there's a way to get to them, I haven't found it yet. The good news is we get it to work here. When we install the app on the actual device, the database goes with it. It gets parked in the right spot because it's all linked into this. So we can test it here. There were some uses for me to get to this database, so I want to show you the easiest way to go find it. Easiest way to find it is to get the program to tell me where it is. So in the application documents directory, that's this guy right here. I'm in the CoreData stack of the app delegate file. This command figures out where is the directory for my database. Not where's the database itself, but where's the directory. So underneath that, what I suggest you do is simply return, that's already there, I'm sorry. I put that there just so you could read it in case you forgot to check. I did that for some students last year, forgot to check CoreData, so they couldn't see what I was talking about. So that tells us where it is, it figures it out on its own. using a pretty complicated default manager, URLs for directory, file manager class. So that's not what we're interested in. If we want to know where the database actually went, we go to the connection string, which is this persistent store coordinator. And right here, it figures it out, including the failed bank SQL light link that didn't happen for me in my office. So if I want to see this, all you have to do underneath here is just print it. So I'm going to do a print line and say that the database directory is colon and then a backslash parentheses. Let's just put our URL in there. That URL should have that information. And at this point, we should be able to run it. And I'm a little curious now because when I ran it in my office, I got nothing. But now that it's done some linking, I'm curious to see whether I get some failed banks on the list already. I don't think I will, primarily because there's nothing that tells it to take the field from the bank database and put it here in the master detail view. We haven't done that yet. But we should be able to run this. Go ahead and run it and find out where our database directory is.
It's not the file that you brought
I
in.
ran it, and as I anticipated, there's nothing in here yet because we have not told our application where to find the data, what the data structure even looks like, and then we have to tell it to get me that field data and stuff it into the cell at row, same way we did before. I'm sorry, I didn't. You got to talk louder. I'm getting old.
It's persistent though. If you add records, then close it and then reopen it.
It puts dates, times in there just like it did before, but it's not putting anything. If it's putting it into a database, it's putting it into a time managed database, and who cares?
But it is persistent.
But it is persistent, is what he's telling us. So if we were to add a time here, there we go, and now kill this and run it again, that time will still be there. That's what you're telling me. But it's putting it into a different database, which is interesting because I thought it said it was writing to failed banks. Well, it might be. But it doesn't know what the structure looks like. But this isn't even what I'm interested in. This is. Down at the bottom, I said print line, so that puts it into this Outlook. And here's the data or output. Here's the data directory file. Oh my goodness.
I have a different folder.
Yours is going to be different.
Not just
All right. First of all, your folder, your user folder is going to be different. So that should be different. But then what happens is iOS creates these unique identifiers for not only your project, but also the data folder. How would you like to go dig that out? Not a whole lot of fun. What I'm going to recommend you do is start at the word library and copy all the way, or highlight to the end and copy that to the clipboard. Don't forget to use Command-C instead of Control-C. And then if you want to find that folder, it's not easy to do. I'm going to open up a Finder window. And I'm going to go to my user directory. And notice there's no library there. There's no library there. And according to this, the path we just copied, there's a library. How do we get there? Click on Go. Go to Folder. In the Go to Folder, you can type the word library and it will open up that hidden library folder. Or you can paste, Command V, that entire ugly path that we got, and it will take you to that path. And if you show the sequence, holy cow.
For me, it says the folder cannot be found.
Did you go to your user folder first? You have to go to your user folder because that library that we're searching for is stored inside your user folder.
Well, you might be able to copy the whole thing.
You could copy the whole thing.
And that would probably
But the point is, it's in your user folder. And we wouldn't want iOS simulator data shared amongst users anyway, so that's not a bad idea. So I'm in my user folder, and then there's a library, developer, core simulator, devices, and then how do I know which one's my device? Notice all the different devices here. Why do I have so many devices there? That's each of the applications that I've ever run on this computer right now. Each application gets its own device, its own simulator. Inside of there, the device has data. Inside of there are containers for data. And then which application's data? This one. Why are there so many there? That I can't tell you. Then the documents folder, and then sure enough, there's my failed banks SQLite stuff. Whoa. And if I could look in there, as Nick mentioned, I would find that it has created for me in the failed banks SQLite database. That's the name of the database. It has created for me, something just occurred to me as I'm talking, but it has created for me inside there a field called time in some generic table. And every time we click the button, it creates a new time and it puts it in that database. I think we are going to need to mess with that just a little bit, because what just occurred to me is if it creates it blank like this on the fly, why would it load data from someplace else? I think what's happened is it's created a name called failedbanks.sqlite. It hasn't put any data in there. It has not copied my database. So what we're going to have to do is tell it to copy data over to that, and we may not get to that today.
Is it just named after the Swift project?
It might be just the project name. And because we named the project the same thing as no, see, that is the project name. You're right. It's not Banklist. It's not that database. So it's not there yet. And I do have some code that I deleted because I thought I didn't need it to copy it in there. We'll fix that. I did keep my old notes just in case I've learned that lesson. All right. So there is a database here, and when we put times in, it got stuffed into there. But we don't want that generic database. But now you know how to find it. I always leave that piece of code in here. So my output, even if there's errors, my output, first thing it tells me is where the database is. And on this machine, the database should always be in the same place for this project, if I need to go messing around in there. Just copying our database file into there doesn't work. As you notice, there were 3 files in there. 1, 2, 3. These don't get created unless these are there. If we just copy our SQLite over there, it doesn't work because those other 2 don't get created. So we've got a little more work to do. But before we can even bother copying our database into there, we need to tell the program how to communicate with it. Last year, I seemed to be going there a lot. I don't know why. But once you found it in the Finder, that folder that's got your data in it, you could create a shortcut, an alias to that, put it on your desktop, so if you ever need to get there again for this project, you can get there very quickly. Or you can take the results of the output from your program, paste it into the go-to window, and jump to it that way. A little quicker. We're going to use an existing database because the program crashed. This is the part here that doesn't quite work yet. I can go in here and say self-application document, put my name, my database name in there, and it will still create a blank one. This is the part of notes that I wiped out. We're going to jump over that. We're going to come back to it a little bit later. This is important. If you modify the data model in any way, you have to delete your app off the simulator. Because if you don't, it's got the wrong data model and it crashes right away. Now we just created our app and we ran it with the generic give me a time table, and now we're going to change the data model. So in about 20 minutes, I'm going to ask you to run this, and it's going to crash. You need to help me remember it's crashing because we haven't deleted it off of the device itself. This tells you how to do it. Pretty simple if you've used iOS before. Just get them to shake and then delete it. But you have to do it manually because it overwrites the program, but it doesn't overwrite the data. And then the data doesn't match the program anymore. So if we change the data model, which is what we're going to do next, if we change the data model, we have to remember to remove the application from the device, which also removes its data. First thing we need to do is set up the managed model. I know that my database has a couple of tables in it, each of which has a few fields. Need to communicate that with iOS. The managed object model does not have to directly relate to the database table. I'm questioning that right now because I couldn't find a way to say only give me these fields. I seem to remember that from last year, but it's not there now. We do have two related entities, so we can create multiple entities. The reason to do this is if you have related entities and you bring in, we have a bank list, and we're going to bring in the name of the banks. And if I have a table that is really huge, we can split that up and say, here's what I need for the lookup, and here's what I need for the details. And the details don't come in until you ask for them. It's another very powerful thing. And we kind of did the same thing in C# in Visual Studio, where we created a table adapter that just got us what we needed for the table lookup grid. Just bring that in, and that was all that was brought in to the program. Again, iOS does it even better than that because it only brings in enough to fill the table for what we can see, and then brings the rest in as it needs them. But the detail view wasn't brought in until we asked for it. Same kind of thing happens here. So again, we're trying to use memory very efficient so we're not sucking in this huge monster database with all its related tables over and over and over again and taking up a lot of memory. Okay, so we need to somehow describe to iOS what our database looks like. To do that, we're going to use this data model. Click on that. And initially it shows you this view, and this isn't bad, but it shows you all the tables. Currently I'm in the event table, and it has one attribute, a timestamp. That's that database that Nick's been playing with. It's persistent. Right, so the good news is that part of it's working, but who needs a database with one table and one field? We need more than that. So the other view, by the way, and I like this one a little better, is this kind of a graphical view. It's an ERD type view. And I don't want this entity at all, so I'm going to select it and delete it. And then we use the magic buttons to describe our database. First, I'm going to add an entity.
How did you get to that?
How did I get this view? Clicked on this, and then on this guy over here with the, looks like a hierarchy chart type of thing. I select this entity and go to the data attributes button, which is this one. And I can change the name of the entity and call it bank info. Just watch Brittany press enter. It's a good idea. If you don't, it doesn't change it until you press enter. And then inside there, we now want to add attributes. Now, one of the things I want to show you is notice that the add attributes button has a little triangle. It means it's a drop down. Well, unlike most drop downs, this is a different kind of object. You have to push and hold to get it to drop down. So if you want the drop down on that, you push and hold. If it ever says add relationship or fetch properties, because whatever one of these you pick class sticks, just drop it down and pick the one you want. Make sure it says add attribute. And now we've added an attribute to our bank. The first field that we're putting in here, I'm just going to call it name. It's the name of the bank. I'm not going to mess with the optional button. You can turn that off and say this is a required field, and that will help a little bit when you mess with the details views, but only when you come back and try to add. If it's not there, it'll yell at you. Well, if I was going to do validation, I would do it in the details view, not when I'm trying to save it. Again, have the database tell me that this is a required field. What you should also do after you've named the entity or the attribute, the field, press enter, is designate its type. And in this first table, everything's a string. Notice once you've designated a string, now there's all kinds of other properties, and you can designate its min length and its max length if you want to. You can designate a default value if you want to. You can put some validation in here if you want to. We're not going to have time to mess with a whole lot of that stuff. It's something you can play around with if you wish. Right now, I'm just going to leave it, giving it a type. Good enough. This is akin to going into Access and saying, give me a string, 255 characters is fine, no default values, no mins, maxes, no validations in Access.
I don't know if Xcode does it or Swift does it, but SQLite doesn't enforce max lengths itself.
So that's why we have to do it here.
Possibly,
Because we're not in SQLite. Right? We're creating, in a way, we're creating a core data object that communicates with SQLite. And so if SQLite isn't going to check to make sure stuff's too big, then I ought to be doing it here. Right? But SQLite also, I don't even know if it even has field size limits. It might not. So it doesn't matter. There's no max. So if there's a business rule, it's got to be in our application. And in a way, that's what we're building here. We can put some of it here. Do we put it here? Do we put it in the details view and write code to validate it? Do we put it in the class itself? We haven't built that yet. We put it in all kinds of places. And the theory behind that is beyond the scope of this class because it's almost December. All right, we need another attribute. So click the Add Attribute button again. And this time we need, get my list going here so I can see it. We need the name, the city, the state, and the zip. So go ahead and add all of those. All of them as strings.
Zip or zip code?
Yeah, whatever. What's a little annoying to me is that I gotta remember to press enter on that attribute name. But the other thing that's annoying is that these are alphabetized, regardless of the way I put them in.
Other ones that push enter, it's like something else.
Does it really?
Yeah.
That's annoying too.
Like if
So
you push
change
enter,
its
you know,
type and then press enter.
I pushed enter, it selected string automatically, so that's
I think you should.
Maybe you might be changing a different attribute. That happened to me. Make sure that they're all, you might click through them here, make sure that city and name and state and the zip all have retained their names and are all strings. At this point, we're ready to add another entity. So let's add another entity. And in this entity, and again, this is all coming out of an SQLite database, and I don't remember there being, I have to look inside there, 2 tables in there. I think these are 2 views on the same table. This is what I need for lookup. And it might be more than I need for lookup, but it gives an example. This entity is going to be some of the details that don't come here. So for this entity, let's call it bank dates. Press enter, add some attributes. Oops. I just added 2 attributes to the other table.
And they'll do it too.
Make sure it's blue. There we go. And the first one is the close date. It's when the bank closed. Type is date. Second one is an update date. Just keeps track of last time this record was updated. It's also a date. And finally, one more, and that is the acquiring institution. I abbreviated that because I didn't want to type all that. Come on. ACQ, INST. You want to abbreviate it differently, go ahead. And that's a string. The next thing we want to do is define relationships between these tables. Now, normally we would do that in all other programs that I've ever used database-wise. We need to have the keys, and notice there's no keys here. All we have to do for MySQL and for CoreData is to simply tell these two entities, again views, that they are related. Behind the scenes, CoreData and SQLite communicate with each other and figure out how. To create the relationship, you pick one table. Let's go back to bank info. And instead of adding an attribute, you add a relationship. Select that relationship. Give it a name. I've been putting REL on it. This is my relationship with bank dates. And the second part is to make sure you designate the destination entity. This is related to bank dates. And then, at least according to my notes, and at least according to the old school, and remember this is a year old now, so it's ancient, we should also define the relationship in reverse. So I'm going to click on.
Can you just click on the inverse?
No, it doesn't do, we will, but it doesn't do the same thing. Bank dates, add a relationship to that one as well. Select it, call it REL bank info. This is my relationship with the bank info table. Here you do designate bank info and you do designate the reverse relationship. So we couldn't define that reverse relationship before because there wasn't one to relate to. So now this says these two relationships are basically the same thing. Before I defined the inverse relationship, there were two connectors. And then when I said this one and the other one are really the same, it merged the relationships.
Does that automatically make the bank date relationship inverse?
Yes.
Well, it's a one-to-one relationship.
Yes, in this case they're one-to-ones. Because one of them is simply a subtable of the other, if you wish, that shows the details that I didn't bring in for my bank info that I'm going to use to fill my grid. And I seem to remember now thinking that last year I should just be moving the bank name and the city in here and everything else goes over in the other table. How you mix and match these is up to you. Let's save that. Let's do a file save. Would have done it if we'd run it. And actually, this made it now. We still can't run this. We're not ready yet. So let's say we save this. Let's take a break. And then when we come back, the next thing we're going to do is create helper classes or wrapper classes to help us manage these two entities, views.
What?